Hi folks, welcome to my Retro Journal. Today I want to talk a little bit about emulators, and I've been actually, it's funny, when I started my my retro channel, it was I called it a journal because that's really what it is to me. It's a journal entry of my hobby, and as you get more into it, it turns out that you're always looking to create content, and you sort of forget that hobby and focus a lot on new things to show viewers, because I'm excited to share. But at the same time, this is supposed to be more of a journal entry of my hobby, and sometimes I get feedback saying, "Oh, you should have a script," or "Where's the music?" And I'm like, "Well, it's a journal entry." But the other thing I've realized is that I actually don't spend as much time on the QL as I want to. I think it's been a month since I actually have used it for anything other than showing folks some cool aspect of it. And so this is the start of early June. I'm a few weeks ahead in my video recordings, and I kind of decided that I've written an emulator. It's actually called a ROM emulator, and what the difference is instead of emulating the chip, I emulate the operating system, or this is ZX81, and initially it seems like it's easy because you're like, oh, you're writing a programming language, a basic interpreter. But it's more than that, because there's lots of nuances here that you have to sort of model. If you model a chip, those are well defined. They're difficult but well defined, and then you have to model also the nuances of whatever auxiliary mechanism it has in terms of memory model and graphics, etc. But still, it's sort of well defined in terms of you can look at the circuit board and the schematics and understand what each chip does. Whereas the ROM, because it's kind of proprietary, it's kind of tricky. And I've discovered as I'm writing my ZXSimulator, there's a lot of idiosyncrasies of the ZX81 BASIC that's really hard to create. And so I've decided, I had done this during the pandemic starting last March in 2020, and I've mostly been using my Windows machine and Notepad and QL emulator because it's just really convenient and fast. And I haven't really worked on it since July of last year, and so I decided that I would finish it on my QL, unexpanded and all, 120K of memory. The things I still have to add is multi-dimensional string arrays, which is actually what I worked on this week, and then floating point, which I have an idea of how to add. Now, there's always first of all, the compiler I use doesn't have floating point. It has floating point libraries, but it doesn't have it natively defined. And a floating point for them is an array, a 3-integer array, so it's 48 bits, which is kind of larger than I want, and so I have an idea of how to represent it as a 32-bit integer as a floating point value. But that's not what I want to get into today. But I'm also interested in emulators because of the PyStorm. So I want to actually get it and then see if I can't try it on the QL, because it's a 48-pin version of the 64-pin PyStorm. If you don't know what a PyStorm is, go Google it and see some YouTube videos. I just bought an Amiga 600, and they're supposedly making one for that. So I'll eventually be able to put it on the Amiga, but I also am interested in doing it for the QL. Basically, the PyStorm is just an interface to the socket of a computer's processor, and you put a Pi on there, and then you emulate the chip. So it's an emulator. And now I've been working on this ROM emulator, but I've written actually other emulators, not real emulators in terms of emulating an actual machine. But this is a book called Analytical Engine. It's kind of interesting. It's kind of a fundamental book on computer science. But what it has in here, which is interesting, is that it has a very simple machine called the I don't know. Well, Pippin is, I guess, it's the Pippin machine, I guess, because they have the Pippin assembler and all. And but it has 15 simple instructions, and it has different addressing modes to where you can. Well, it has actually less than 15. I've augmented this to create 15 simple instructions, and with 4 addressing modes, it's about 60 instructions. And I have actually written this. Let me see if you can actually see it. Sometimes things aren't in focus. Yeah, so it's a pretty generic instruction set, and it has direct, indirect, and immediate addressing modes. I've actually written the emulator for this particular machine, and I've actually done it in JavaScript. One of the thoughts I have is actually to do a series in the summer of doing that, so folks can follow along and actually write their first emulator if they haven't done so yet. It won't do any graphics or anything fancy, but it'll just, run through a bit stream and compute. And so I might do that coming up sometime in the mid or late summer, to do a 2 or 3 part series where I would create the emulator for it and then also write an assembler for it as well. And again, just using JavaScript and an editor, because then you can just use any old browser and any text editor and just follow along. Have a 3 or 4 30-minute sessions, which is all it would take to write that particular emulator, just to show folks what an emulator is actually like. So I've done that. Now, it's not a 68000, which has many more instructions and modes, but it's definitely a simple start to that. I saw someone else do that. I guess you can't see this. I saw somebody else do that on YouTube. And I thought, I should do that. It'd be fun, especially because whenever I do something like that, I end up always learning more about what it is that I'm doing. So, but that also got me to thinking, I have this ROM emulator and I should finish it. And so it's been kind of interesting to work on my QL. The editing isn't bad. And I'm going to go through I'm going to show you what I've done. The editing is actually pretty decent. It has a nice editor called QED, which is very similar to the ED editor on the Amiga and somewhat similar to, it's better than a VI. It's sort of a mix between VI and Nano on Linux, Unix. And then the compiler actually works. I have 4 different modules, so I don't have to compile the whole thing. So the compile is pretty fast. It's the linking that takes forever, but because of the slow micro drives. And I just did a video that showed you how fast all that stuff is. I'm not going to do that again today, but I wanted to kind of go over a little bit of what I implemented, modified on my ZXSimulator, which is a ZX81 ROM Emulator, and then show you a little bit of the code of what's involved, because there's some complexities that in terms of how I've implemented it, and I might have to change that in the future. But so what I want to do is put the camera in front of the computer just to demonstrate that. So let's go and do that and talk a little bit more about the ROM emulator and using, what it's been like to actually, use this. All right, so here we are on the QL, and it's running ZXSimulator. So what I've implemented are, so let me demonstrate this to you. I can certainly use the dim command to do multi-dimensional arrays for numbers. So I can go 1, comma 2, comma 3, comma 4, comma 5, and that works. But for string arrays, dim a $1, comma 2, comma 3, I'm going to hit a max limit, which is not true for a true CX81. So what I've implemented is I used to have a single dimensional array, and I've just implemented 2-dimensional arrays. So I can do something like this, and then I can say let $1 equal A, B, C, D, E. I'm adding 1 extra just to show you that $1, it does cut it off, and then I can say let $2 equal 1, 2, 3, 4, 5. I can do 6. Print $2. So that's been implemented. It also has this cool feature where you can say, you can do this, you can say let $1 2, 2, 3. This is where the craziness comes in, and this is something that integer array is just single array indexing, but this stuff you can do, you can say, you can say X, Y, T, no, fat fingers, and I can say print $1, and you see that it is substituted. If I just say let $1 2 to 3 equal asterisk. If I, oops, I don't know what happened there. Let $1, 1 comma 2 to 3 equal H. Print $1. Whoops. $1. Yeah, so what it does is it puts a space where, because I was trying to set 2 spaces, but I only had H, so it treats the remaining as a space. And this is actually very similar to ZX81 behavior. And again, I still have print $2, which were my numbers, so they're still there. So let me demonstrate to you how this works on the actual ZX81. I have it running as well, so. And screen's going to be a little different, but here it is. It can be, let's do a new on the screen. Let's see if I need to adjust the, that's a little better. So again, here I can go dim $2, 4, and then I can say let $1, definitely the QL keyboard, so much better, equals A, B, C, D, E. Again, adding 1 extra because it's only 4, and then print I'm much more of a touch typist. So you can see that it does cut it off, and then I can say let $2 equals 1, 2, 3, 4, 5. I'll give it 6 even though it's only 4 spaces, and print $2 gives you that. Yep. And if I go let $1, comma 2 to 3 equal X, Y, print $1. You see that again it did the same thing. You have AXD. I know it's fortunately it's hard to. I can try to adjust the exposure up. That's a little better, but then the bottom is not so good. So yeah, I don't know why the top is. It's actually pretty evenly white on my. But if I play with the exposure, yeah. So if I go let $1, 1, 2 to 3 equal H. Print $1, delete it instead. You can see that it's AH space D. So the same thing happens. Now, one cool feature it has, and this also works on mine, you can say print $2, comma, and just do 2. So no starter, no end, and it just assumes upper and lower and upper bounds, right? So this will actually do this whole thing. And so, yeah, so it's really crazy stuff that, of course, you can also just go print $1, comma 2, and it'll just get you a single character. So that sort of works, but it has that range stuff that you can only do that in the first. So you can't do print $1. I just don't have my finger on the right, so I can't say 1, 2, 2 in the first one. So that's an error, and I can't say 1, 2, to 2, comma 1. All right, so it doesn't let you do it in the first part. So in fact, it doesn't even let you finish that statement. Okay, so let's go back to the QL. So when you write a ROM emulator, you actually have to spend a bit more time trying to investigate how this all works. Let's see how the screen here is. Yep, so it's going to have to be adjusted a little bit. Okay, so, and again, I can do the same thing here. I can say print $1, and it'll do the same whole thing. By the way, if I say print $1, 2, it actually lets you do it. So it's a little bit friendlier than, well, on the ZX81, if you type 2, you're always going to have a space before and after. So I didn't actually try to add that in. Wait, what did it actually do? So that was actually an error. Print $1, 2. So it actually should have given an error, but it only printed A. So that's actually not working properly. Plus, you saw that when I was doing something with, when I'm hitting that key, so I think it crashed. So somehow the asterisk key is causing an issue. We're going to have to reboot. So here we go. Super excitement about having to reboot. I can test to see if MDV6 ZX. So this is my previous version, and I can see if the asterisk key is causing an issue with my. If I think it's got to be a problem in my new version. I have to figure out what I did wrong. But yeah, so if I type the asterisk key here, oops. Yeah, so that's perfectly fine. So it's just the syntax there, but for whatever reason, MDV8. So this is my new version. It's a little bigger, but it's having some memory problems. And that's just the nature of when you're adding a new feature. You always destroy something else, and could be that I'm not that I'm overwriting memory. I'm not because I'm creating and deleting a lot of memory to get this multi-dimensional array stuff to work. And I'm going to show you this next. I'm just going to see if so this is the new one. So if I do, oops, yeah. So it was probably just because memory had been overwritten. But let me demonstrate to you this other thing. So I actually have a little program that shows you this. Load MDV8 test BAS. And this one kind of demonstrates to you the problem that I'm having. And I might have to go and change the underlying format that I've read in. Basically what I'm loading in is what appears in files. So if I have this, you can see this is a little program. And if I run it, it works as expected. Oh, it doesn't. I see what the problem is. I have it as, so I guess I had a bug in here, so this should say left, that's why. All right, here we go. Yeah, so this, you can see it. So this is running, and you're like, oh, well, no big deal, right? So, but the big deal is that these strings aren't equal. This string takes up 5 bytes, this takes up 10, and this takes up 15, because if you look at the underlying representation, MDV8 test BAS to con, you'll see that the way this is stored in on the file and then also internally in memory, that inverse characters are actually pairs of characters, and graphics actually have a backslash and two characters each. And so that's actually how it's stored internally, and I actually have to deal with that, and that actually adds a lot of complexity. So let me show you. MDV, this is the Q editor, and I'm not going to have this video go too long. We're at about the 20-ish minute mark, but just wanted to show you, so I'm not going to do compiling, etc., because I've already shown that. Just wanted to briefly show you. The code is not great, but the issue here is because I'm dealing with, so if I go MDV3 and I'm going to take a look at the command one, because that kind of shows you the mess that you have to do. And so because it's going to take a second to load, and you know, this will also show you how I maneuver around. Again, the QED is actually a nice editor. It's really well written. Jan actually just released the newest version, believe it or not. So you can go F3 find to the let command. Takes me right where I want to be. And so this is the mess. So basically what this code says is, I'm doing a let. So the way variables are stored is it's either going to be a bunch of letters, and you can have spaces in a variable name in ZX81, or it's going to be a bunch of letters ending in an open paren that says it's an integer array, or it can be a bunch of letters and spaces with a $, which is tells you that it's a string. And so what this says, if it's not an integer array, then if it's not an integer array, if it's an integer array, get the index. Otherwise, just to set the index to 0. Then if it's not an assignment, then basically what I have is what I'm expecting is a variable name with a $, and then open and close parentheses with a range. And that's what this is. This fetches the variable and then gets the actual range of it. And the range is the thing that figures out it's either a single range, 5, so a $, open paren 5, close paren, or it can be more complex range, a $, open paren 5 to 6. Or now that I've added multi-dimensional arrays, it can be the range can be a $, open paren 2, 2 to 3, close paren. So that's and all the range does is it sort of computes what that is, because your string array is just a long binary byte stream, and then the row and column stuff you sort of figure out. So if you're at row 2, column 3, and you have a 2x10 array, then you're at location 13, right? So it's 10 plus 3. And so then you have a start location of 13 and an end location of so if you're of 13 if it's a single, if it's a range, it's 13 to 14 perhaps, or 15. And that's what this figures out. But so then you think that the rest is easy. However, the problem is that I need to go through and actually parse and deal with, like, well, what if I have inverted or graphics characters? Because then instead of just incrementing a single time, I got to increment multiple times, and that's what this switch statement does. And I have it a bunch of times. So here in this middle part, what I'm trying to compute is so I'm potentially substituting some string. So for instance, if I say let a $, if I have a single dimensional array and I say let a $, open paren 2 to 3 equal xy, then this figures out how much to remove and how much to replace it with, because what could be at location 2, 3 could be graphics characters, which take up 3 bytes an index, or they could be inverted characters, which takes 2 bytes, or they could be single characters, regular characters, which takes 1 byte, and then the ones I'm adding. So I've got to do sort of this offset and compute this g to, these are the ones I'm removing. So every time I get a graphics character, it decrements g once and then twice. And if it's an inverted character, it only decrements it once. Notice there's no break. If you know how C works, there's no break between the case statements. So if it does the first case, it actually does G minus minus twice. This is a way to save space a little bit. It's kind of a programming trick. And then, of course, in the end, I got to do lots of, here's where I copy and merge the two, the 3 parts to it. So the first one is to merge the first part of the array, then the new element, of the array. If I have any, well, this is the first part of the array, then the new part. If the new part was shorter, there might be some spaces I have to add. And then the final part, I go from in reverse order and just add that in. So usually you have 3 parts when you're trying to insert something into a string: the beginning, the middle, and the end. And then also this while loop here. If my middle part is shorter than what I'm inserting into, and that was the example where I had A, B, C, D, and I was inserting H into it, and I was inserting it into locations 2 to 3. Notice that it gave A, H space D, and that's where the space comes in. So it's complex because you have to sort of deal with keeping track of all these things. And that's only because of the way I've implemented it. I wanted to just keep the source file internally. Now, one way to simplify this is if I actually get rid of these markings and just have when I read and write the file in and out, I can translate it. And this stored internally as bytes above 128, which are the special printing characters in ASCII, right? And the QL has its own special set. And then just, because when I print the stuff to screen, I actually don't print the ASCII characters. I have graphics routines that actually, when it's an A, it prints a ZX81A, so that gets remapped anyway. So it wouldn't be too hard. But in any case, just to show you some of the things that are involved in doing this, so this is my let command that I've modified. At the top of it too, the last thing I'll show you, because we're at the 30-minute mark almost, is that the dim command is going to come up right here. And this is the first thing I modified. And, you know, the thing I always struggle with here is the fact that I'm trying to not have this grow too much. In fact, this addition of a second dimension cost me about 500 bytes. So I'm now at about, I was at 48.6K. Now I'm at 49.2K. So yeah, it added about 500 bytes. And so I'm trying to keep this program as small as possible. So here, I basically parse the dim command, and if in this do loop I generate, so if it's an integer array, it's easy. I just if it's a 2x3, if it's, let's say 3 columns, 2 rows each, I need to set aside 6 integers plus the it's a 2x2, it basically has 2 dimensions, so I need to set 2 more integers for the dimensions, and then 1 more integer that tells me how many dimensions I have. So that'll end up taking 9 integers worth of information. But since it's all uniform, it's pretty easy. Because I want my string just to be literally a piece of memory that contains a string, I initially made it a single-dimensional array. So when I decided to create a 2-dimensional array, notice right in here, I actually checked to see if the val2 integer is what that stands for. If it's greater than 2, then I've reached my max limit. In other words, my dimension can't be greater than 2 if I'm dealing with a string, which is what this says. So if it's 1 or 2, then my variables, so I'm not using structs because it's kind of a pain to do in Digital C, which is a small C compiler. So what I have instead is I have three arrays of variables. One is var nam, which is the name, right up here. Var ptr, which is the pointer to some dynamic memory that gets allocated, and that's where, for instance, my arrays for my string or my integers go. And then I have var num, which is just used if it's a simple numeric value. Well, it's not being used when I create an array, so it's just there and it sits at 0. So when I decided to create a 2-dimensional array, I said, oh, what if I just put, since it's only 2-dimensional array, I need to know the second dimension, right? Because if it's 2 by 10, then every time I go, row 1, I go from 1 to 10. Row 2, I have to add 10. I have to add that dimension. That's how you unroll a 2-dimensional array into a single dimension. So that's what I do here, is I just stick that second dimension into this unused number locator for that particular. So the variable is designated by this index, which says, oh, and that's a hash value that I get. That says, oh, a $sign is at this index. And so var name, var num, and var pointer all get referenced with that. And so I wasn't using that num index, so this is what I'm using now to create my second dimension. So that's why it's limited to 2 dimensions. I'd have to create an additional data structure if I wanted to actually have more than 2 dimensions for my string array. I will say that it's probably not that needed, so I don't have to be 100% compatible with the ZX81 ROM. A lot of times people will create a 2-dimensional string array because they want to maybe store a picture in there, so lines and columns of a picture that they can draw or text that they can write. To have a 3-dimensional string array, it's been very rare. I haven't seen it. If you have, I mean, certainly on the ZX81, you can do as many as you want. I mean, you know, as I don't know if I showed this, but on the ZX81, I can do crazy stuff like, this is going to be bright again. There we go. So I can go and I can say dim $2, comma 2, comma 2, comma 2, comma 2, comma 2. I can do as many of these as I want, and it's perfectly happy to do that. But I don't know what use it is. So, you know, I mean that my ROM emulator is going to have its limits, and I think one of them is maybe just support two-dimensional string arrays, unless it becomes. I mean, I might have to change the whole internal structure for this. Right now, it's growing a bit more than I want. So maybe if I turn this into, I mean, the other option is I could use instead of using the pointer var to create one long stretch, I could use the pointer var to create a list of an integer array that themselves are pointers for each dimension. Is one way to do it. But right now, this was an easy fix because I already had the single dimension. I wanted to add the second dimension. So I just used this unused one to give me that second dimension that I then read to see, like, if it's 0, that means I have a single dimensional array. If it's not 0, then I have a multi-dimensional array with that holding you know, what that second dimension is, because which I need to unroll a two-dimensional array into a single dimension. So if it's 10, if it's 5, 10, then I have 50 items, and I have to move 10 items. So, you know, 2, 1 in a dimension 5, 10 array is 21, right? So it just says 2 times the length of the second dimension, and then add 1 to it. And that's why I need that 10 or whatever values, and it's stored in this var num. So that was easy to do. And again, there's lots of memory allocation and deallocation. And my fear, of course, is, am I running out of the, you know, if I'm running past the end of a string of a piece of memory that I've allocated, then I'm overwriting memory. And when you saw that particular error that I was showing you in the, when I was using the ZXSimulator, you saw when I hit asterisk, it did a bunch of crap on the command line. That probably means I have a memory leak somewhere, or I'm overwriting memory. And I'll have to fix that. So it's buggy, so it's not ready for prime time yet. This is, yeah, so we're about 27 plus, 37 minutes. So I'm going to have to edit this a little bit. But this is the other place what I've been working on. And I will end here just to show you. Also, I'm worried that I'm going to run out of space on my camera whenever it gets too long. But let's see if this kind of shows you, though. Yeah, I'm able to read in my modules. They're about 12 to 14K in size, and I'm able to jump around pretty quickly. So if I find, and I kind of remember multi. So this is the range program that sort of figures out what my range is, whether it's two-dimensional or one-dimensional. And here, this basically returns the substring that I want to grab. So this is the get range function. In any case, so yeah, I decided to do some real work on my QL, and am compiling and using it. So that, because it's my hobby. So instead of using emulators, it's going to be slow, but I think it's fun. I've really enjoyed using the QL to do this compilation, and QED is a nice editor, and I've already shown you how you compile stuff. So yeah, that's my hobby, and I wanted to share that with you. So thanks for joining me today on my journal entry.